Do you deal with Ansul systems? We do from time to time. Ansul system is the suppression system that gets installed around a kitchen hood vent system, so that if there's a fire, the Ansul, it's basically like a big fire extinguisher, will put out the fire, but it has to have an electrical interface with it. Most of these hoods come with especially captive air, they come with a control panel already built in and actually pre-wired for all the relays and things. With hoods, if you've ever been in a commercial kitchen, there's the little round pull station that's by the cooking area, and it'll say, pull or pull in case of fire. What it actually is, there's a cable on the inside of it that goes up through a conduit, and at the top of the conduit at the 90, there's a mechanical pull, like a pulley system, and it goes back, and however far it has to go to get to the actual Ansul box is what we call it. But all that is a place where they store, well, not store, but they have the fireproofing chemical that sprays out on the grease fire or whatever it is under the hood if they pull that. But in order for that to work correctly, with the exhaust fans and the makeup air, the exhaust fans pull out the smoke just in case there's a fire. It actually pulls out all the fumes and some of the heat, but there has to be a makeup air fan which pulls in fresh air from the outside. I'm not a fire suppression expert, but I do know how to wire the systems up, and so you have to know a little bit about how they work in order to understand what you need to do as an electrician. And so, but the makeup air, or the supply, you may see it called, that actually feeds fresh air in, and it kind of keeps the balance of pressure inside correct. They want you to have that makeup air. We just looked at a system just now, priced it, but they didn't go for it, which is fine. We had to travel about an hour away to look and get a quote together. It was in an old Chinese restaurant. They took out the old hood and put a new captive air system in, and we were going to have to pull a new control circuit into this box. So that'd be a 12-2 MC cable on a 15 amp single pole breaker. That would come and that would be the control circuit wiring. I may be able to thread some pictures in to kind of show you what the control box looks like, but you just have a terminal block in this control panel where you land your hot and your neutral, and that actually will distribute through the system. It's already pre-wired. It'll use that power to turn on the lights that's under the hood. It'll use that power to power the control board that is in the hood. It'll use that control power to power on the VFD that they're using for the makeup air system. It will use that control power to run through the micro switch of the Ansul system, and I do believe it will actually use that same 120 volts control power to run through the gas switch. Some of these jobs will have a mechano-electrical gas switch. Some of them will just have a plain mechanical switch that there's no electrical interface to. The one we went to today had a mechano-electrical interface. I would imagine it's similar to the Ansul system, mechano-electrical system. So when you pull that Ansul system cable, it releases a spring. The spring kicks up a mechanism inside the box for the Ansul system, and that then triggers a mechanical switch, a plunger, that trips a normally open contact to a normally closed, or normally closed to normally open. I think in this case we were going to be landing on the normally closed to feed back to the terminal block that's in the control panel. So if something went wrong, it'll kill everything except the exhaust fans. You have to kill the makeup air and anything electrical under the hood, receptacles, stove, deep fryer, whatever the case may be. This particular one did not have any electrical under the hood, so we only were concerned with getting power to the makeup air, which would have been a 3-phase circuit, 15 amp, and then 2 exhaust fans, 2 single-phase 208 volt 15 amp circuits. Interestingly enough, back in the day, when we were building these out ourselves, you brought everything into one box or something close by the hood, the end of the hood or whatever, or close to the Ansul box where they keep the big fire suppression chemical, and you'd have to build everything out with contactors. Well, now you can take, for the exhaust fans on this particular job through captive air, you can take the power from the breaker box straight to the fans, a switch on the fan box up on the roof, and then they actually have controllers built into the fan assembly, and it could be the fan motor itself, I guess, but it's a low voltage cable, and it'll run back, and that will actually tie into the control board on the control box of the captive air hood system. So you don't even bring line power into the captive air hood system anymore. You just take that straight to the exhaust fan. However, the makeup air still comes to the captive air control panel. It runs through the VFD. VFD, from the way I understand it, I'm not real good with it. I haven't done them a lot, but a variable frequency driver is what I think it is. If you in the comments know any better, I'm sure that you will correct me. But the way I understand it, in America we have 60 hertz power, and it's for the wavelength of your power, right? The sine wave, I guess. How frequent it passes a fixed point, that peak of that wave, and it's programmed to be the same. And so the way I understand a variable frequency drive is that it changes that frequency. Maybe it gets a little slower, which makes the motor run a little slower, or it gets a little faster and it makes the motor run a little bit faster. And so for this particular Ansul hood suppression system, we run a 3-phase circuit through the control panel onto a couple terminals that they already have pre-wired. It's really nice. And then you run another 12.3 MC cable or conduit or whatever you decide to run to, just ran a red light. Whoops. To your makeup air hood, your makeup air fan up on the roof. And so when you break it down bit by bit, it's a lot more simple than some people make it out to be. These hood systems actually will have temperature probes in them too that will override any other setting, like the push button settings on the side. The push button settings on the side will control your lights and your fans on or fans off, and it's actually interfaced through a digital interface with your Cat 5 cable that comes in right through the side of the control panel into the face of the hood system, and you can see it just from the ground. It's the way the workers can control manually on and off, and it comes in, plugs in through a Cat 6, Cat 5 jack, just a male end. It's almost like a patch cable for a computer, plugs right onto the board. But with the temperature probes, there's typically, depends on how long the hood is, from what I understand, but at least one. For this one, there was 2 temperature probes just kind of, spaced out, hanging down from the inside of the hood, and that's just a low voltage connection that comes and lands on the board. That I guess mechanically, if they close and or open, I don't know how they're programmed, if they're normally open or normally closed, but if that temperature reaches a certain temperature before the fans are on, these temperature probes will automatically turn the fans on regardless of any input from the worker. And there's also a room temperature sensor, works in a similar fashion. And I'm trying to think, I believe that about covers everything. As an Ansul Hood System control panel wiring lesson, so to speak. I don't think there's anything else. There's different variations that you're going to find. You'll have to figure out on yours if you have different power that's going to be under the hood. Like I said, that all has to be shut off. Sometimes you got to run it through shunt trip breakers. It's going to be very similar to how it works with your Ansul system. It's just it's dry until the control panel sends power through, or it's already sending power through the whole time, depending on how they've wired it up. But anyway, it can be an interesting little project. I was apparently underbid by like $2,000, but time constraints is one of our biggest things right now, and we were trying to work this in for this company, and they decided that their time wasn't as valuable as what they thought it was. They sent us out with a sense of urgency that they couldn't find anybody else to do it, and we got there and gave them our price, and lo and behold, they do have time, and they had somebody else lined up to give them the price. They asked me to work with them, and I came down $500, but that still wasn't enough for them to go for it. So I took my guys on the project, thinking that we might be able to do the job once we got a price and an approval. But it ended up being a half-day learning experiment for my guys. But anyway, that's how it goes sometimes. All right. Like and subscribe if you haven't. Have a good day.